Welcome to the lecture series on electromagnetic theory. This is the syllabus and it is important for all the competitive exam like CSIR, JEST, GATE, TIFR. So for this syllabus I am following the David J. Griffith book. So before studying this syllabus, we have to know the mathematical method that can be used during this syllabus. So the mathematical method for the electromagnetic theory, first I have started from the differential calculus and now the ordinary derivative. So if any function is a function of single variable, so the total derivative can be written del f by del x into dx, and if we change x by an amount of dx, then f changes by an amount of df. The geometrical interpretation for this is df by dx tells the slope of the graph of function f versus x. Now, gradient can also be defined in terms of this. So, let's any function f is a function of three variables, suppose x, y, and z. So the total derivative can be written in terms of partial derivative del f by del x into dx plus del f by del y into dy plus del f by del z into dz. So it can be written as del f by del x x cap plus del f by del y y cap plus del f by del z z cap dot dl, and after that it can be written del of f dot dl, where del of f is del f by del x into x cap plus del f by del y into y cap plus del f by del z into z cap, and it's called the gradient of f, and the gradient of any scalar field will be a vector. So the geometrical interpretation of the gradient is its it points the direction of the maximum increment of the function. Here we can see in the figure the gradient, the point, the direction of the gradient is along the maximum increment of the field. Here, because here the 2 plus charge and here is the single plus charge, so the direction of the gradient is along the maximum change in the function. And similar in this figure, here two negative charge and here one negative charge, so the gradient tells about the maximum increment, because here more, here less negative of charges and here more negative of charges, so it tells about the direction of the increment of the scalar field. So we can see from the example. So here in this example, there are four examples in which we have to find the gradient. So let's solve one by one. So first one is given r equal to under root x square plus y square plus z square. If we see, the gradient of f is defined as the gradient of any function is defined as del by del x into x cap plus del by del y into y cap plus del by del z into z cap of f. So we can apply this. So gradient of r equal to del by del x cap of r plus y cap del r by del y plus z cap del r by del z. So let's simplify only one. X cap del r by del x, and we know that the r equal to under root x square plus y square plus z square. Now let's differentiate. This is the x cap, and if we differentiate, here 1 by 2 terms comes outside, and if we differentiate this, this gives 2x and into x square plus y square plus z square, and here power minus half. And if we simplify, 2 and 2 cancel out, this will be x by r, because here under root 1 upon under root x square plus y square z square can be written r, and x cap. So similarly for others, gradient of r will be here x by r into x cap plus, and similarly for y cap, del r by del y will be y by r into y cap and plus z by r into z cap, and this can be written as 1 by r x times x cap y into y cap and plus z into z cap. So this will be vector r by r, and we know that the vector r can be written r into r cap by r. Here r and r cancel out, so this is the r cap. So this is the solution for the problem. So what we can get from this? So if we choose any sphere of radius r, so if we take the gradient, so it tells about the direction of the r, and that will be the maximum increment about this field r. So this is the direction of r cap. So this tells about the direction for the maximum increment of the field or of the vector. So in this way we can calculate, we can solve the other problem also. So here I left the other problem and solve only problem D. So D is solution for D. Solution for D, we have to find the gradient of r to the power n. So similarly, we know that the gradient, this is the x cap del by del x into r to the power n plus y cap del by del y into r to the power n plus z cap del by del z into r to the power n. So similarly, we can solve only one, and similarly for other we can write. So x cap del by del x, here r can be written x square plus y square plus z square power n by 2, because we know that the r equal to under root x square plus y square plus z square. So let's differentiate this. Here x cap, and we can take outside n by 2, and this will be x square plus y square plus z square power n by 2 minus 1 into 2x. This can be written as n times x cap into x and x square plus y square plus z square power n minus 2 by 2, and this can be also written as n x x cap by r to the power 2 minus n. So this can be written as, or if you have problem, this can be also written like this: nx x cap into r to the power n minus 2. So whatever you want, you can write. So similarly, gradient of r to the power n will be n x x cap into r to the power n minus 2. This is for the first term here, for the first term. Similarly, for the second and third will be n y y cap r to the power n minus 2 and n z z cap r to the power n minus 2. So here we can take common n r to the power n minus 2 and x into x cap plus y into y cap plus z into z cap, and this can be written n r to the power n minus 2 into vector r, and we know that the vector r can be written r into r cap. So this will be n r to the power n minus 1 into r cap. So uh, both are correct. So if you want to write anyone, you can write. So if you can verify all the previous question, here I have solved for A, B and C, all are you can verify from this. So this that is all about the gradient. Now we can go to the next, the divergence. So it is defined at the dot product of any vector. So the divergence of V can be defined at x cap del by del x plus y cap del by del y plus z cap del by del z dot vector V x cap Vx plus y cap Vy plus z cap Vz. And divergence of any vector gives the scalar quantity. Now the geometrical interpretation of divergence is del dot V is measure how much the vector V is spread out diverge from a point. So here we can see from the example. So here suppose we have a positive charge and we know that the electric lines come out from the positive charge. So we can see like this in any book of electromagnetic theory. So here the electric lines are diverged. So here divergence of any quantity is positive if electric lines are divergent. Similarly, for negative charges, we know that the electric lines come towards the negative charge like this. So the divergence of this will be negative. Here we can see in the figure. First, when the for negative charge, because divergence is negative, and here the for positive because the its divergence outside. So we can calculate the example. We can calculate here these problems. So the divergence of V. So we know that the divergence x cap del by del x plus y cap del by del y plus z cap del by del z, and dot. First here I have taken example A. So here x square x cap plus 3x z square y cap minus 2xz z cap. So here we know that the dot product with x and x will be 1, and x cap dot y cap will be 0, and x cap dot z cap will be 0. So here the dot product will be del by del x of x square plus del by del y of 3xz square and plus del by del z of minus 2xz. So this will be 2x, and here this will be 0, and here will be minus 2x. So it gives the 0. So its divergence is 0. Divergence is 0 represents there are constant increment or decrement like this. So the magnitude of these vectors are similar. So here the divergence shows 0. Similarly, if we find solution for B, the divergence of V can be written as x cap del by del x plus y cap del by del y plus z cap del by del z dot x times x cap plus y times y cap, sorry, minus z times z cap. So this will be del by del x into x plus del by del y into y plus del by del z into z, and this will be 1 1 plus 1, and this equal to 3. So here is constant divergence. Positive divergence means it diverges outside. So all the example you can solve. Here only in z direction is variable, so its divergence found only 1, and here z cap, so it gives the 0 value. So you in this way you can find the divergence. Now next we can go to the curl. Now the curl basically the cross product of any vector. So this is the three-dimensional cross product. So here let's V can be written Vx I cap plus Vy j cap and plus Vz k cap. Then it's defined the divergence of V equal to determinant of I cap, j cap, k cap, del by del x, del by del y, del by del z, and Vx, Vy, Vz. Curl of a vector quantity is a vector, and curl of a scalar is meaningless. So we can only take curl of any vector quantity. Now the geometrical interpretation is the curl of a vector measures how much the vector curl around a point. Here we can see in the figure. Here here we can see the vector have curl. So if we see the magnetic field, any magnet north and south, so we can see that the electric lines, the magnetic lines come out from the north and going to the south pole, so it diverges. So sorry, so it's curl. So in this way we can see the curl of any magnetic field will not be 0. curl of B, and this gives the Ampere's law. That's why here is important for the electromagnetic theory, these mathematics. So here we can calculate the curl of any vector field. It's very simple. Now the curl of a vector equal to I cap, j cap, k cap, and del by del x, del by del y, and del by del z. X cap is minus y, and y cap is x, and in z it will be 0. So if I simplify this, so I cap here 0 minus del x by del z, this also will be 0, and similarly minus j cap, this will be 0 minus del y minus and minus plus by del z, this also gives the 0, and similarly k cap del x by del x minus and minus plus, and this will be del y by del y. So this will be 0, this will be 0, and here del x by del x will be 1, and similarly del y by del y will be 1. So here we can get 2 times k cap. So we can see here this is the vector quantity. So curl of any vector is also a vector quantity. Similarly you can solve b also. So this all about the curl, and now we are going to discuss the uh, vector product and identities. Here we know that the normal the divergence or of any scalar f plus g, so we can just uh, write divergence of, sorry, gradient of f plus gradient of g. Similarly, if we want to calculate divergence of any vector quantity a plus b, so this can be written divergence of a plus divergence of b, and the curl of a plus b equal to curl of a plus curl of b, and here k is the here k is scalar, uh, scalar, or it can be constant. Now the gradient, now the gradient of constant times any function, any scalar function, so it can be written as k times gradient of f, and similarly uh, divergence of any constant times any vector, so we can take an outside the constant, and the divergence of a can be solved directly. So, and this is also curl of any curl of a constant times any vector, so curl of a can be written and k taken uh, outside the bracket. Now here from 7 it is important, 7, 8, 9, 10, 11. So now divergence gradient of two scalar quantity like f and g. So gradient of f and g can be written f gradient of g plus g gradient of f. On in it, divergence of any scalar and vector means divergence of a scalar times vector can be written as scalar times divergence of a plus vector a dot gradient of f. This is important and it can be used in the electrostatics. So in ninth, the divergence of A cross B can be written as B dot curl of A minus vector A dot curl of B. And in 10th, the curl of scalar times vector can be written as the scalar curl of A minus vector A curl of gradient of F. And now the in 11th, uh, the curl of A cross B can be written as B dot del in the bracket and times vector A minus A dot del times vector B plus A del dot B minus B del dot A. Now here the second order derivative in 12th and 12, 13 and 14. Here this is the identity. The curl of gradient is always 0. Here we can written Cg equal to 0. The curl of gradient equal to 0. Similarly, divergence of curl will always 0 means dc. Divergence of curl equal to 0. And in 14, we know that the curl of A equal to gradient of divergence of A minus del square A. So that's all about this is all about the vector calculus that can be used. In the next lecture, I am going to discuss about the different coordinate system like Cartesian coordinate, spherical polar coordinate, and cylindrical coordinate. So, uh, if you like this lecture series, please like, share, and subscribe. Thank you.